Hello students, here we are in our Unit 1 Section 2 notes on quadratic graphs, and this time we've moved into Part B, quadratic problem solving. So quadratic problem solving basically means word problems that end up with x squared in them. So let's look and see how that happens in this one. We've got a swimming pool 6 meters wide, 10 meters long, surrounded by a walkway of uniform width. So here's my walkway. Uniform width means that this length is the same as this length. I'm going to call those lengths x because we haven't been told the width. And of course it's uniform, so down here is also x, and over here also x. The area of the walk happens to equal the area of the pool. So the area of this walkway, well, this total length of the pool plus the walkway, I see that as being 10 plus 2x. This total width here is going to be 6 plus x, so 6 plus 2x. And if I want the area of just the walkway, so I'm going to make myself a little formula, area of the walkway, that's going to be the big rectangle, 10 plus 2x times 6 plus 2x minus the area of the pool, which is 6 times 10, so that's 60. Of course, the area of the pool is just the 60. We're told that those things are equal. So AW equals AP. If I set those equal to each other, 10 plus 2x, 6 plus 2x minus 60 equals 60. Now I've got a quadratic that I need to solve. And one way that we haven't looked at solving yet is with our calculators. So I could make this a little bit easier right now and make this equal to 120. So 10 plus 2x times 6 plus 2x, just move that 60 to the other side, make it 120. And let's look at graphing with our calculator. So if we come into our calculator, I'm going to clear this off. I'm going to go into y equals. Remember we had changed our y equals setting, so let's make sure to make those back to lines. So I'm going to change this setting back into just a normal line. Normal line there, okay. I'm going to do that with my red one also. Change that back into just a normal line. Okay. Now I'm going to clear out what's here. So for my second equation, I'm going to put in 120. And then up above, I'm going to clear this out and put in my 10 plus 2x. There's my x. Close the parentheses. Put in another set of parentheses. 6 plus 2x. Close the parentheses. So right now, straight away, I want to think about my window. I know that my y value has to go at least up to 120. So I also know that my x value needs to be positive, but it's a quadratic, so it's possible there's more than one x value. So right now, I don't have a feeling for, actually that's not true, let's come back and look at this. I know that this x value has to be less than 6. Actually, it has to be less than 3, because if this was 3 and this was 3, then we'd have no pool in the middle, because 3 plus 3 would make a total, that doesn't make sense. Sorry, no. I take back what I was saying. Anyway, thinking about a width of a walkway, I'm guessing it's going to be around 1 to 2 meters. So right now, I'm going to leave my window settings for my x. I'm going to go negative 10 to 10, just to have a feel for it. But my y's, I'll keep that negative 10 there, but I'm going to come all the way up to 200. And I'm going to count by 10s, because counting by 1s is way too many. So let's see what that gives us. All right, so there's my quadratic. That's the left side of the equation. And there's my 120. And like I suspected, there are two answers. There's a solution over here and a solution over here. But this negative x value makes no sense. So I don't even want to consider that one. I want this positive x value, which looks like it's somewhere between 1 and 2 meters. So let's look at that. So I'm going to calculate the intersection point, that's number 5. My first curve is the parabola, my second curve is that straight line, and my guess is that it looked somewhere in between, so I'm going to call it 1.5. And again, our guess is always the x value. All right, so here is my x value, and it is a decimal, so let's slide this over here. Okay, so now as I think about this solution, I'm ignoring the negative value, but I want to know that you know there were two solutions. So if we write that x has to be greater than 0, therefore one solution at x, and then it's not equal because I'm going to have to round this. So x is approximately 1.57 meters. Let me go back and make sure that I've answered the question. What is the width of the walk? So actually, I'm going to take this back, get rid of my meters here, and put that in my answer. The width of the walk is is about, and I want to make sure to use that word about because otherwise it implies exact, is about 1.57 meters. Okay, so using the calculator is a really smart way to continue solving this. Of course, you could keep doing it algebraically. You could multiply it out and use it one of the 4 methods we discussed previously, but you have this technology and you should use it and use it well. So that's the way to do it on this problem.